Hi there. So, since you are reading the Meadows book this week, the first couple of chapters, I wanted to use the lectures to do some kind of parallel concepts around systems. So some of them are specifically mentioned in the Meadows reading, and some of them aren't. But it's my hope that all this vocabulary will be stuff that we'll be using for the rest of the semester. So that's why I wanted to just do some fundamentals in these lectures that I'm posting for this week. So what this series is going to do is introduce some basic system concepts, including of what systems are, and what feedback is. I'm going to introduce some of the features of community systems and introduce the assignment. And so this first lecture is just on some basic concepts, and then the second lecture is on features, and I'll talk a little bit about the assignment. So why are we learning this? It all seems pretty abstract. Well, I think, as I already talked about, I see sustainability and resilience as system properties. And so it's very important from that point of view that we understand what systems are. I also think that looking at systems and learning to look at systems helps us understand complexity and helps us understand how to make our ideas more effective and more implementable. So, and that's what I mean by saying a design or intervention. If we say, you know, I think we should do X, then we should have some way of sort of figuring out how X, what its consequences are going to be, intended and unintended. And to me, that's what systems thinking helps you do. So a lot of people write about systems, and I've got a definition here from another author named Capra. A system is an integrated whole whose essential property arises from the relationships between its parts. So that's, you can see how that echoes the definition that's in the Meadows reading. And systems thinking is the understanding of a thing, a phenomenon, within the context of a larger whole. So when we're doing one kind of thing when we are systems thinking, we're doing another kind of thing when we are analytical thinking. I don't mean that one is more valuable than the other. It's just they serve different purposes. And admittedly, some people are better at one than the other. It's just a part of how our brains work. So analytical thinking is when you understand something or understand a problem essentially by taking something apart, by figuring out what its components are, by by getting into the details. So for example, and to me these are different questions. So say if I had a car, an analytical question would be, what is wrong with this car? What is the number of the tow truck driver? And so an analytical thinker might examine the parts of the car to determine what is wrong with the car. Oh, look, the wheel is in the ditch. You can tell the complexity of my mechanical thinking. House, if you're looking at a house from an analytical point of view, what are the number of kinds of rooms in the house? What's the square footage? What is it built of? What's the foundation made of? Systems thinking, typically you're putting the thing into the context of a larger whole and some purpose for which it is produced. So for a car, what's the purpose of this? And I just put mode of transportation. I'm already suggesting a purpose for a car. but you know, some cars are not part of the transportation system at all. They're part of a roadshow system. They're part of status symbol systems. No one drives them at all. They just sit in a garage, or no one drives them at all except to go to shows. Those cars are not part. They're not modes of transportation. They have different purposes. But that's a systems view. So what infrastructure does it rely on is very important when you're looking at a thing from its purpose view. You know, what's it for? And what do we need in order for it to be able to have that function? So we need to have gas stations, we need to have roads, we need to have a fossil fuel industry, we need to have, you know, to have a fossil fuel powered car be a mode of transportation. We have to have all those things that we're providing. And say we look at a house from a systems point of view, you know, you can look at it from the point of view, what are the economic relationships that produce this house? You can look at a house as a thing that is produced by our tax policy, the way that our tax policy favors home ownership as a type of sheltered investment. So you can actually see a house or a housing form as a feedback in the tax policy, in the tax system. Or you can look at a house as, you know, like in relationship to jobs and educational systems. You can look at house as an element in a land use and transportation system because it implies certain kinds of modes of transportation more than others. Or you can look at houses in terms of what family and social relationships they imply. We how do you call this culture? The middle class culture from about the 60s, you have this little bungalow which gradually expands until it looks kind of like a small town. But if you look at the design of what's called even a single family house, it's modeled on the nuclear family. It's not modeled generally on an extended family. And when we see houses or, you know, residential objects that are extended family dwellings, you can get quite a negative reaction. You can see that in Vancouver because there are extended family dwellings being built in Vancouver. They're quite large, and they're not to the middle class single family house aesthetic taste. And it can be a little bit more than a matter of taste when you are doing housing assistance. And so if you were thinking about one kind of family model that works in your socioeconomic model of the family and applying it in a different culture where that is not how the family works, then you can take an object and put it in a different system and cause problems. You can think about communities as systems. I like these sort of air photo type of views because you can see the water system and the transportation system, and you can see how that view, there's a sort of an area, an industrial and transportation area, and then a commercial area. And, you know, it's sort of those kinds of pictures appeal to planners. But an analytical thinker might observe one feature at a time and explain each feature. You might look at the bridge and how the bridge is supported, you know, and how it spans the river. A systems thinker might ask, what are the forces that produce this place? How do these areas come to be separated? How what role does regulation play? What role does soil play? What role does the flooding regime play in how these areas come to be in the arrangement that they are, and the community has the system functions that it does? So systems are, I should say, systems are made up of informational or energetic relationships. Go back to that Capra definition, between objects or processes. Sometimes an object is a process, like if you have a factory in your system. So I'm going to go ahead and say that it's the arrows between the boxes that are what creates the system. Although, you know, you could say, as Meadows does, it's the purpose that creates the system. But the part the reason I say that about how important the arrows are is because, in my experience, that's the hardest part to get people to draw or to understand. Or what are those relationships? What are those feedbacks in the system made of? It can be energy, like sunlight, can be fossil fuels, can be calories, money, affection. So communities are systems, and there's an optional reading, so I might refer to Hall Smith, which is one of your optional readings this week. I just thought I'd point that out. Communities can be seen as a child raising system, an economy and infrastructure system, an environmental system. So the perspective, your purpose in looking, also affects what you're going to see as an object and what you're going to see as a relationship. So I want to talk about a couple of concepts. We talk about feedbacks and then go through positive feedback, negative feedback, and a delay. And so a feedback, the easiest way to describe it is when one action causes another action, but not in a, this doesn't mean, it's not the same as you know, deciding who's responsible for a, you know, it's not a criminal sense of causation, right? It's just a descriptive sense of causation. So but I thought I'd go with a restaurant example because I use a lot of food examples in this series of lectures. So at my restaurant, I serve you a meal and you give me money. And that is our basic, that's our immediate feedback relationship. But you might also write a review on Yelp, you know, which is another kind of feedback. You might also tell your friends. And of course, as a restaurateur, I'm you know, buying my produce and I'm giving feedback to my suppliers in terms of money. I'm paying my staff, which is a feedback with my employee relationships. So positive feedback is when more of something makes more of something else. It's not when I'm nice to you. And sometimes I get them confused because we do use them. We use them in common language to mean, you know, when I say good things about you or when I say bad things about you. But in systems theory, it's positive is more and negative is less. Whether sometimes less of something is good. Like, anyway, don't want to be more confusing than it's absolutely necessary for me to be. So, for example, if I'm, you know, in a restaurant, if I put more food on the plate, that might mean that I have less money at the end of the day because I've given more to my suppliers. So that would be a negative feedback. But maybe I have more customers, and that would be positive feedback. Or maybe in another scenario, I figure out that I'm going to be a fancy restaurateur, and so instead of making larger servings, I'm going to make them smaller. And I'm going to charge 3 times as much for them. And so when I do that, I give a negative feedback to my suppliers because I don't need as much food. And but I get more money, and maybe I have more customers. And those are both positive feedbacks. And one of the most interesting things in all kinds of economic choices, all kinds, food systems, banking systems, commodity systems, is when there's a delay in the feedback. We have entire industries set up around delay in feedback. They're called hedge markets. And also, of course, they're a permanent feature of environmental problems. For example, climate change. Obviously, the carbon goes up and has been going up for since the Industrial Revolution. And there's a very large delay in the feedback. And it's also a very impersonal feedback. So I could be the biggest polluter of the world, and I might not suffer either any more consequences, or I might even suffer less consequences than people who don't pollute at all. But back to the restaurant example, you can also have a delayed feedback with the Yelp review. You know, maybe I tell you the meal is good, but then, you know, a week later I write a scathing review on Yelp, and that's a delay. And when you have delayed feedback, it causes problems. Because you don't have the information you need to, you know, stop serving the ketchup on the macaroni and cheese. You need that feedback, you know, right away, so that you can adjust how you're behaving. So now feedback loops. There's reinforcing feedback loops and balancing feedback loops, and Meadows talks about these. And I wanted to really give an example from the Hall-Smith reading. But this is where the cause and effect reinforce each other. So more of one thing leads to more of another, which is leading to more of the first thing. So Hall-Smith talks about traffic congestion as being an excellent example of this. If you have there's a road, and, you know, people are moving to the outskirts, and so there is increased demand on that road, private use of the public road, until the state of traffic congestion, and everyone is, we need a bigger road, we need a bigger road. So then the government opts to build a bigger road or expand it by a lane or something like this, because that will solve this traffic congestion problem in this one place, which reduces the time travel and increases the likelihood that people are going to be able to locate even farther out, more people. And so then you have more people living farther out, a higher demand on the road, until you once again reach some state of traffic congestion and increased demand for another lane. So that, you know, it's very common example of, you know, how it is that cities become so sprawling. It's interesting that it's not really the narrative in Prince George, except for probably some lane expansions on the major highways, which is part of the narrative. So those reinforcing feedback loops are what we talk about when we say either a vicious cycle, which is the example I just gave, or a virtuous cycle, which is where a good thing makes more good things. So for example, as if you were doing you know, making the downtown, you know, a place where people felt more comfortable on the street, you would need to get more people on the street. And once you have more people on the street and more eyes on the street, people will feel more comfortable there, and more people will come, and more businesses will be able to open. You know, that is so there you have a virtuous cycle of inhabiting a place. And then the other kind of feedback loop is a balancing feedback loop. a system that tends towards equilibrium instead of either growth or decline. And Meadows is talking about thermostat systems. We also see, we do see some balancing systems in nature, although they're not always, they don't always seem as pretty. But a population relationship between an animal and its food is classically a balancing loop. So if you have a certain amount of grass and the deer population increases to the extent of that grass, and then you have a bad year, or else there's just overgrazing to the detriment of the grass species, and then you have a die-off, and then you have more than adequate grass the next year after there aren't very many deer. So it's sort of it is a balancing loop. So the terms in this first part, system, as more in Meadows, is emphasizing a set of relationships and structures arranged around a common purpose or function is a system. A system property is actually something we're going to talk about later. I've hardly talked about system properties, so that's actually in the third section, I think. We've talked about positive and negative feedback and two kinds of feedback loops. And those are the ones you'll actually, most likely you'll choose one of those kinds of systems to draw for this week's assignment. So we'll end there for this section.